Alright, so we're going to use Lagrange multipliers to find the maximum values of the function of x, y, and z subject to constraint g. So I'll start by getting del f, and del f will be just partial respect to x is 2, partial respect to y is 2, and partial respect to z is a 1. And now I'll do lambda del g. And let's see what we get. Here's our constraint right here. The constraint right here is g. So partial respect to x is 2x, partial respect to y is 2y, partial respect to z is 2z. And I will distribute those lambdas to all three parts. So I'll be 2x lambda, 2y lambda, and 2z lambda. So here's the system we're going to solve. We're going to solve this system of equations, where 2 equals 2x lambda, 2 equals 2y lambda, and 1 equals 2z lambda. 2 equals 2x lambda, and 2 equals 2y lambda, and 1 equals 2z lambda. One more thing I'm going to write this constraint down, because that's part of the system we're going to solve. So, and x squared plus y squared plus z squared equals 9. So let's see. What does lambda equal to here? Or what does x equal to? We can solve for x, solve for y, solve for z in terms of lambda, put them all in here. So let's see, what does x equal here? Divide it 2, I get 1 over lambda. Alright, what's y equal to here?
Same, 1 over lambda.
1 over lambda. And what's z equal to?
Half lambda.
Yeah, divide it 2, and the lambda will be in the denominator, right? Like that?
Yeah.
Is that right? 1 over 2 lambda in the denominator. I'll put them back right here. So I'm going to substitute all three of these into this. We'll get, okay, 1 over lambda squared plus 1 over lambda squared plus 1 over 2 lambda squared equals 9. I'm going to solve for lambda. So that's 1 over lambda squared plus 1 over lambda squared plus 1 over 4 lambda squared equals 9. Now, how do we solve this? I can multiply 4 lambda squared on both sides. So I'm like, if I do that, I get 4 lambda squared
Plus 4 lambda squared.
all over lambda squared plus 4 lambda squared. Lambda squared. I'm just multiplying 4 lambda squared on both sides plus 4 lambda squared over 4 lambda squared equals 9 times 4 lambda squared. So what's that come out to be?
Hold on 1 second.
If I do that, what's the left side turn into? That's just multiplying 4 lambda squared up.
No, it's 1 lambda squared. 4 lambda squared plus 4 lambda squared plus 1 lambda squared, right?
Oh, so this last part?
Yeah.
Yeah, let me do that. And what I'll do here, in fact, I think an easier way, you're right, Art, I'm thinking an easier way to solve this, in terms of this, I can just do common denominator,
Yeah.
right? I think that's easier, I'm going to do that. Multiply 4 over 4, multiply 4 over 4, and that'll be easier than multiplying that LCD on both
Yeah.
sides. So now I have 4 plus 4 plus 1 over,
9.
so I get 9 over 4 lambda squared. Yeah, I totally agree, that's the
Right.
easier way to solve this. So I can multiply that up here and divide that, and I got 1 equals 4 lambda squared, right? So let's see, if 1 equals 4 lambda squared, 1 over 4 equals lambda squared, so lambda equals,
Plus and minus half.
good job, plus or minus the square root of 1/4, which is plus or minus a half. So, we're getting 2 answers. So let's plug them back in. What's one of the answers? If we use lambda equal to a half,
So
we get 1 over 1/2 is,
2.
that'll be a 2. 1 over a half is a
2.
2. And 1 over 2 times a half would just be a
1.
1. That's one answer. Now, if lambda equals
Negative.
negative 1/2, right here,
So negative 2.
negative 2,
Negative 2.
and what's this one?
Negative 1.
Cool. And these are the 2 points that we're getting. Use Lagrange multipliers to find the maximum values. So how do we know which one gives the max value of f and which gives the min value of f, we just gotta plug these back into what?
Original
This is the
equation.
last step. We'll just plug these two back into here to see which one gives us a max value and which one gives the minimum value. And obviously, everyone, if we plug in a 2, 2, 1 into this, f is the maximum value of, this gives the maximum value of f to be 2, 4 plus 1 is 9, right?
Uh-huh.
So the max value of f is 9. This point, we plug it in here, is
Negative.
a number of f equal to -9, so this would have to be the absolute minimum value. And this would give us the minimum value of f. There we go. This point gives us the max value of f. This point gives us the minimum value of f. Under that constraint. And that's it.
Alrighty.
Thanks. Thank you for doing it.
Sure.